Hello everyone, my name is Shepard Duff, and I'm a technical artist here at Motorized Precision. Today, we're going to be talking about how to work with nodal points. So your first question might be, what is a nodal point? The nodal point is where light passing into a lens converges, and the image flips. In computer graphics, this point can be considered the origin of the camera's perspective. When we want to line up live-action footage with a virtual camera driven by robot data, we need this virtual camera to line up precisely with the nodal point of our real-world camera. So how is a nodal point different from a sensor offset? Well, when we design moves in MP Studio, we usually use the location of the camera's sensor as our pivot point. This helps keep the center of mass close to axis 6, which gives us less movement overall, making it easier to accelerate and allowing for smoother and faster moves. This results in movement very similar to how your eye or your head would turn, which feels quite natural to work with. Since the sensor is looking down the center of the lens, we can still do accurate nodal rolls. But if we pan or tilt, this configuration produces a parallax effect. In most cases, this is not a problem, and it's a fair trade for the extra agility we get. However, if we wanted to do a panorama, then this parallax would be an issue. To achieve a panorama with no parallax, we would need to pivot around the camera's nodal point. Now we can see that the parallax is gone when we pan. Notice though how the camera and the robot have to move a lot more in this configuration. Now that we know what a nodal point is and what we need it for, how do we find a nodal point? Well, first we need to find our sensor offset, and there are a couple ways to do that. The first, and probably the quickest method, involves using a caliper to physically measure the sensor offset. On a standard dovetail mount, first we need to measure the vertical distance from axis 6 to the sensor. An easy way to get this measurement would be to measure the distance from the top of the dovetail mount to the side of the lens, then subtract 2 mm for the inset mounting point. Then we can measure the sideways distance from axis 6 to the sensor. We can take a similar approach here and look at the offset of our lens compared to the dovetail mount. Usually the holes on these mounts are placed in 10 mm increments, so frequently this can just be eyeballed. Finally, we can slide the camera forward or backward so that the witness mark is directly under axis 6. This would make our forward offset 0. If we're using a C bracket, we first need to measure the forward distance of axis 6 to the sensor. This one is easy. We can just measure from the back edge of the C bracket to the witness mark on the camera. This time, we need to subtract 6 mm for the inset mounting point. Then we need to measure the horizontal distance from axis 6 to the sensor. This will most likely be a value in 10 mm increments, like with the dovetail mount. Finally, we need to measure the vertical distance from axis 6 to the sensor. This one will be a bit trickier because the lens tends to be further from axis 6. You could use something with a straight edge as a guide, or you could try lining this last one up visually. This brings me to the second, easier method. It takes a bit longer, but we can accurately measure 2 of the 3 sensor offsets visually just by entering jog mode and observing the lens as we roll the camera. If the lens appears to stay in place, then we've calibrated our offsets correctly. We can also look through the monitor with a crosshair placed in the center as we roll the camera to see if our image rotates around the crosshair. Now that we have our sensor offset, we can find our nodal point. We can do this by finding 2 reference points in our workspace, one very close to the camera and one very far away. We want to line them up so that the far point is directly behind the near point. It can be helpful to make a new timeline and set a keyframe so we can come back to this point as we test. Now we can jog the camera and pan side to side and observe our monitor. If the near point moves away from the far point, then we're not nodal yet. Keep adjusting the forward offset in small increments until the foreground and background both move at the same rate when panning. This is our nodal point. If we need to do a panoramic shot, then we can just use this as our pivot point. But in most cases, we want to write down the difference and revert back to our previously measured sensor offset so the camera pivots around the sensor instead. Since we're not designing a panoramic move, I'm going to select my forward sensor offset, and I'm going to cut and paste it into my forward nodal offset instead. Now my camera moves as expected, and my viewport and any exported moves will match the real-world camera's footage.